All right, welcome to Notes. Today we're on lesson 16.2. That's on page 219 in your book. We will be adding some definitions, so you should be doing this. So today we're going to learn about what's called the reciprocal functions. You might have covered this in Algebra 2. You probably did, but you just don't remember it. The reciprocal functions are named that because reciprocal, remember, means to switch the places of the denominator and the numerator. So if we remember, we have the sine theta, and if we remember SOHCAHTOA, that means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Here they want us to put it in terms of x and y. So this is going back to what if we have an angle. In standard form, we draw that reference triangle, and we have x, y, and r. So if we really want to put it in those terms, which we don't have to for this lesson, we have theta down there in the corner. It's always down there right by the origin. Opposite would be y, hypotenuse would be r, adjacent would be x, hypotenuse is r, opposite is y, adjacent is x. So again, if we think about the unit circle, that makes sense. We said sine is y, cosine is x. In the unit circle, we don't have an r because our radius is 1. But when we do our reciprocal functions, right, cosecant is the reciprocal of sine. So that means 1 divided by the sine of theta, which for us, that means we take the reciprocal, so it'd be h over o. And if you want to keep it in terms of the reference triangle, that's r over y. So if we keep going, secant is the reciprocal function of cosine. So that's 1 over cosine of theta. So that'd be h over a, or in terms of our reference triangle, r over x. Lastly, cotangent is the reciprocal function of tangent. So that means 1 over tangent theta. So a over o. And in terms of our reference triangle, that'd be x over y. So when we look at all of this, we might get a little bit overwhelmed. But the way I remember it, and unfortunately it is not so easy, we would hope that sine and secant match because they're both the ones that start with a s, right? Cosine, cosecant, they sound similar. But unfortunately, because of their reciprocal functions, they change as well. So sine turns into cosecant, cosine, the reciprocal is secant, tangent turns into cotangent when we do the reciprocal function. So let's actually see what this means for us. We have these angles, and it's saying use the unit circle to find the value of this. So secant, we said secant is the reciprocal function of cosine, but we actually have our degree here. So we could do it that way, right? We have our unit circle, we have 45 degrees. The values here are square root 2 over 2, square root 2 over 2. We know that cosine is our x value, so we have 1 over square root 2 over 2. We don't like fractions on the bottom, so we'd actually multiply by the reciprocal. So we get 1 over 1 times 2 over square root 2. So we get 2 over square root 2. We don't like the radical in the denominator, so we have to rationalize the denominator. So we get 2 over square root 2. The bottom, square root 2 times square root 2, means we can get rid of the square root, but then these cancel out. So all of that work just to get that the secant of 45 degrees is the square root 2. A lot of work. We want our answers to be exact, so we do actually have to do all that work. Moving on to the cotangent of 2 pi over 3. So we could say, again, reciprocal function, right? So it's 1 divided by the tangent of 2 pi over 3. Or we can say, using our definition, the cotangent is x over y. So we can go in, draw our angle at 2 pi over 3. Whoa. And our x and our y value is -1/2 and then square root 3 over 2. So let's start plugging it in. From our unit circle, our x value is -1/2, and then we have square root 3/2 on the bottom. We can multiply by the reciprocal, so we have -1/2 times 2 over square root 3. These two cancel out, so we have -1 over square root 3. Again, we don't like the square root on the bottom, so we have to rationalize the denominator. So we get negative square root 3 over 3. Moving on. We have the secant of 270 degrees. So again, reciprocal function. We would want to find the cosine of 270 degrees and put that on the bottom. If we look at our unit circle, 270 degrees is right here. That value is 0, -1. Cosine is the x value, so do 1 over 0. And that will get us undefined. So the secant has an undefined value. And we talked about what happens when we divide by 0. When we talked about rational functions, there's a special graphical thing that happens there. And that's what we're going to talk about on Wednesday. The cosecant of 7 pi over 6. We never did pi. Oh, yeah, we did. So let's look at our unit circle. So 7 pi over 6 is right here, and the value is -3 pi over 2, the square root of -3 pi over 2, -3 over 2, and then -1/2. So we want secant of 7 pi, the sine of 7 pi over 6. Sine is the y value, so we do 1 over -1/2. Again, multiply by the reciprocal. Ones cancel out. It's kind of the extra step that we don't always need to show, so we get -2 as our answer. So we can see here how using the unit circle can allow us to get exact answers for a couple of our values. But it's not all the math we ever have to do. So if we keep going in through our book, we have these situations where we give you a coordinate value, and we have to find all of the trig values. That's not quite what I'm going to have you do today on the worksheet. So let's move more so towards something that I'm going to give you on your worksheet. I'm going to give you something like this. Still not really. I'm going to give you a triangle that's filled out, and I don't think the book gets into it like that. So let's just use this example. So tangent of theta. We have theta down here. Tangent is opposite over adjacent, so we'd have 4 over 3. On the worksheet, I give you all 3 of the sides. So that means this side has to be 5. We're not going to worry about this for your worksheet. We'll come back to this about what all of that means. So instead, on your worksheet, the triangle is given, and you just have to remember the definitions of sine, cosine, tangent, secant, cosecant, and cotangent. So you have this triangle. The worksheet just asks for 1. Let's find all of them. So the sine of theta, remember that's opposite over adjacent, or that's x over y, the way that we have it drawn, because it's in standard form, not x over y, I apologize. Sine is y over r. So in this case, in either case we think about it, it would be 4 over 5. And that can be our answer for sine. Cosine theta, we have adjacent over hypotenuse, or x over r. So here we have 3 over 5. Again, simplified as it gets. Tangent, that's the work that was given to us. We already know what it is. So let's do the other stuff. Sine, its reciprocal function is cosecant theta, which is just flipping the fraction of sine upside down. So it was 4/5, now it will be 5/4. Cosine, again, just flipping the secant theta is just flipping the cosine upside down. So if our cosine was 3 over 5, our secant turns into 5 over 3. Tangent, its reciprocal function is cotangent. So if we had O over A, we get A over O. If we had y over x for tangent, then we have x over y for cotangent. So in this case, we just flip the 4 over 3 upside down to get 3 over 4. So that's how we could find any of the values. Now let's move on to the next one. Again, we have a triangle. Here's theta. Secant is the reciprocal function of cosine. So this is actually h over a. So here that means here's the hypotenuse. Here's the adjacent. I won't have you do this, but we could actually solve for the y here. We would do 5 squared plus y squared equals 6 squared. So 25 plus y squared equals 36. So y squared equals 11. So y equals the square root of 11. So here we're going to have a radical that we're just going to have to deal with. So let's go through. Again, on your worksheet, you just have to find one of the trig values, but let's talk about how we could find any of the trig values. So this is where you start with on the worksheet. You have the triangle, it's all filled out, you have some radicals to deal with, and then I tell you which one to find. But let's just find all 6. All right, so sine is opposite over hypotenuse, but we can also think about it as y over r. So in either case, opposite is square root 11. The y value is square root 11, so that goes on top. The hypotenuse goes on the bottom, or the radius goes on the bottom, right? We have x, y, and the radius, or the hypotenuse, the adjacent, and the opposite. So we divide by 6. That's in exact form. There's no way we can clean that up. Cosine is the adjacent over the hypotenuse. So that is 5 over 6. Tangent is opposite over adjacent, or y over x. So here we do square root 11 over 5. So those are the first 3. Those are our original tangent trig functions. Now let's do our reciprocal. So we have sine. If we find its reciprocal, we get cosecant theta. Notice how I'm spelling cosecant, abbreviating cosecant. Cosine, if we find its reciprocal, we get secant. And then tangent, if we find its reciprocal, we get cotangent. So when we start doing this, we can just take our answers, turn them upside down, or we can go back to the original triangle and do it that way. In either case, we get 6 over square root 11, 6 over 5, and 5 over square root 11. So here is the only answer that we can be fine with right away. Here we need to rationalize the denominator. So here we get 6 square root 11 divided by 11. We can't simplify that, so we're done with that. Again, rationalize the denominator. So we get 5 square root 11 divided by 11. So on your worksheet, we have a triangle, and you have to find the given trig function that I asked for. When I return on Wednesday, we'll go over a little bit more complicated case of when we have an angle in this kind of format, where we don't just have a triangle, we actually have a more complicated situation, kind of like what we started talking about in the first half of this video. And then we'll actually start talking about what happens when we graph these reciprocal functions. We haven't graphed tangent yet, and then we need to figure out what happens when we put a trig function on the bottom of a fraction. It's going to get interesting, it's going to get complicated, and some of us still need to go back over how to graph a function that's sine and cosine. Good luck on the worksheet. Hopefully it's a nice little break from graphing, just learning some new trig functions and finding our fractions. Good luck.